Hi everyone, welcome to another video. We are talking today about graphing, and what we're going to be doing for the remainder of this series is graphing different types of functions as well as relations. So we're going to cycle through a bunch of very new concepts. So we're going to go through this quite slowly and really kind of dig into what makes these graphs look the way they do. So what we're looking at today is the graph of a circle. Now, we've looked at these a lot in terms of geometry and things like that, but now we are looking for ways to sketch this on a Cartesian plane, on an XY axis. Now, the formula for this, which we're going to dig deeper into, is this thing here. X squared plus y squared equals r squared. Now, for a lot of you, this is going to be really new. So you're going to be thinking, well, what the hell? Everything we've been doing so far is like y equals something. Or like we can rearrange it to make x or y the subject. Now, we can do that here as well, but there's actually a pretty interesting reason for why this ends up being the particular formula. And having it in this type of form, the x squared plus y squared on one side equaling to r. Now, the r here is the radius. That's what the r means. And we're going to look really quickly at why the formula is the way that it is. Now, let's just consider a circle. So this circle is kind of right in the middle of our xy plane. So we have the origin here, this point 0, 0, and each length from the center out to some edge, so here or here or here or here, or even here or here. I haven't drawn this to scale or very nicely, but each of those lengths is just the length of a radius because the center is at 0, 0. And we're going to, let's actually just see if I can move this at all. Okay, that looks a bit nicer. The center is at 0, 0, and each length out to the edge of the circle, or the border of the circle, this is the length of r. So from 0 up to this point, this is a length r. From 0 across to a positive x value, this is also a length r. And whatever this distance is, when we look at these 2 points, I'm just going to have negative r because this is in the negative x direction, this is in the negative y direction. So we've slightly mapped out how this looks, but we still need to understand why this formula is the way that it is. Now, the radius is always constant for a circle. It's going to be the same wherever we go. Now, let's say we drew a line from the center out to some point P, and it has some coordinates x, y. We have this particular point here, and stretching from the middle out to the border, that gives me again my radius of r. And this means that essentially my y value, my kind of height up from the center, is going to be the value of y. So I'm going to write that in here. I have a height of y, and I have a horizontal component because we're going this distance along. That's a distance of x here. So I'm going to put in x up here. Now, what do we notice about this particular thing? Well, my x and my y, what angle do they meet at? And what type of shape have I formed between this little imaginary x horizontal line and this vertical line y and my length of r? Well, I have made a right angle triangle. So I'm going to draw this little symbol in here to show that this is, can't get this right, can I? To show that this is a right angle. Now it's important to note that the X and Y axis always run perpendicular. So this is a right angle here. And no matter where I draw these, they're always going to meet at right angles. So I have something pretty cool here. I have a triangle that I can construct with the radius, with the X component, Y component, and the radius. And no matter where I draw this, if I do another line, say up here, let's make this slightly different. I still have my radius here, and let's call this point, I don't know, Q, X, Y. I have a vertical component, Y, and a horizontal component of X. And I have another right angle triangle. Now, every single time I have the same radius. Now, what do we know about right angle triangles? Well, we know that the hypotenuse, so the side opposite the right angle, so this side and this side, so we're going to call that C squared, is equal to the square, well, my one other side squared plus my third side squared. So C squared equals A squared plus B squared. So my hypotenuse here squared equals the sum of the other two sides squared. Now, just substituting these all in, I'm always going to get a radius of r. So even if I draw this here, my radius squared is always going to be equal to my x component squared and my y component squared. So what we're going to do here is we're going to substitute in my values from my little right angled triangles I've constructed. And that's going to give me that r squared, because that's c, my radius is my hypotenuse, is equal to x squared plus, x can be my a here, whoops, x can be my a and y can be my b. So I get r squared equals x squared plus y squared. Now, it doesn't matter what way we write this. We can do this as the x squared and the y squared on one side. But we're going to get this particular formula here. And this is the equation of a circle. Now, let's apply this to one question, because now we have a picture of what this kind of looks like and how we can make sense of this formula. Let's apply this to a question. So we have an equation of x squared plus y squared equals to 4. Now, all circles in this particular form, there are no actual horizontal or vertical shifts happening. So when we plot this thing on, this is for a circle with the center at the origin at this point 0, 0. So for part A, we want the coordinates of the center. These, when this is in this particular form, will always be 0, 0. The coordinate of the origin is, or the coordinate of the center of circles in this particular form with nothing acting on the x squared or the y squared, no horizontal or vertical shifts, we say the center is at 0, 0. Now, if you need a refresher on transformations of things, so transformations of parabolas or other graphs, and when I talk about these vertical and horizontal shifts, please look at some of those videos. Now, the second part B, we want to find my radius here. So, remember our equation is going to be x squared plus y squared equals r squared. But now here my 4 is my radius squared. So I'm going to set r squared to equal to 4. Now, remember, this is going to be equal to this just based on our formula. So I want to find what my radius is. So since my radius squared is 4, then my radius will be the square root of 4, because I can take the square root of both sides. And I get a radius of 2. So this is how we can calculate the radius. And this kind of makes sense because even though we're given a whole number, we just want to find what the square root of that number is going to be. That gives us our radius, because the radius squared, a number squared, gives me 4. Okay, a couple of questions just to practice substituting in values. We want to find y when x equals 1. So we want to substitute 1 into my formula. So I have 1 squared plus y squared equals to 4. 1 squared is just going to be 1, and we can subtract it from both sides to get me my y squared. Y squared equals to 3. And then my y, taking the square root of both sides here, is going to equal to plus or minus the square root of 3. Now, one more, practicing this. I want to find value of y when, find value of x when y equals 1/2. Now, same thing, I'm just going to substitute this into my equation. So instead of the y, I'm going to put 1/2 squared equals to 4. Now, 1/2 squared gives me 1/4. So I can subtract from both sides. I can take a quarter away from both sides. And I wind up with x squared equals to 15/4. And I just want to take the square root of both sides, which leaves me with x equals to plus or minus the square root of 15 over, now the square root of 4 is going to give me a nice number, so I'm just going to write that as the integer 2. So this is how I can find what this graph kind of looks like. And this can sort of help for like point of scale. So if you're sketching this graph, you want to include a point of scale, you can pick an x or y value, substitute it in, and that gives you an idea of where everything's going to sit. And now finally, we want to sketch this. So I have my xy plane, I have a circle, and its center is going to be at 0, 0. Let's move this around a bit. Okay. We have its center at 0, 0. We have a radius of, we found that before, a radius of 2. So that means that wherever we stretch out, it's always going to be 2 units in length. So I have 2, 2. Now here in the negative side, I have a value of -2 and -2 here. So I have drawn this, and because this is a radius, these are going to be my intercepts here. And we can also get that by substituting x equal to 0 or y equal to 0. And you will see that your intercepts, you're always going to get plus or minus 2 for x and y. So you guys can try that in your own time, but since we already know the radius in the center, we can just draw a circle because we know the radius is going to be equidistant in all directions from the center here. And if we wanted to, we can draw in one of our points of scale. Let's pick a nicer one. So when x equals 1, y equals plus or minus root 3. So when x equals 1, for example, y is going to be positive root 3. So here's 1. It's either going to be positive root 3, or substituting that in as well, I get also negative root 3. Now, just for a quick recap, we noticed that one value of x, substituting this in, gave us 2 values of y. Now, is this circle, does this mean the circle is a relation, the graph of a relation, or a function? Now, if we remember, a function means that there is one value of y for one value of x. There's this one-to-one idea. I put one thing in, I get one thing out. In this case, however, I'm putting in one value of x and I'm getting 2 values of y. I can do the same thing here. One value of x gives me 2 values of y. So we can write a circle, or the graph of a circle, is a relation, not a function. This is just to recap some of the ideas we were talking about for functions and relations. But this is how we can make sense of the formula of a circle, how we can use this to make sketches, and in the next video we're going to look at intersecting circles and lines. So going back to this simultaneous equations idea we talked about earlier in the series. But that brings us to the end of the video today. Thank you so much for joining me, and I will see you next time.